well, not mean, but the variance, okay? Here we go. Instead of working with the MGF, we're going to work with the log of the MGF, and we'll call it K, right? It's just a new function. This K, which is the log of the MGF, is called a cumulant generating function. And it works similarly with the MGF, so we look at the first derivative with respect to t and set t to 0, that's going to be equal to the mean. If we look at the second derivative and set t to 0, that's going to give us the variance, not the expected moments squared. In other words, using the cumulant generating function, gives us a chance to find the variance quicker in fewer steps than using the MGF. So let's show you how here. So MGF, let's just write that down again. MGF is 1 minus p plus p to the e to the t all raised to the power of n. This is for a binomial. So we have that the cumulant generating function kt is going to be the log of this guy, so it's going to be n log 1 minus p plus p e to the t, like this. Okay, using the log rules. Now let's scroll up. Now, the first derivative of t of a cumulant generating function with respect to t, that's a log function, so we know, and we can use a chain rule here because inside the brackets there's a function of t. Let's just kind of give you a recap here as well. D by dt, log of t is equal to 1 over t, right? So this is going to be n times and then 1 over this guy, all that lot, which before I called LT, so let's just do that again. We're using the chain rule, so we have to multiply by the derivative of inside here with respect to t, so it's going to be PET. So therefore we can say that the mean is just going to be this cumulant generating function, first derivative of it evaluated at t is 0. Okay, right, let's write down, before we found that L0 is going to be 1, right? So here it's simply going to be n p e to the 0 is 1. Throughout we're going to be using repeatedly like that. Okay, e to 0 is 1, L to 0 is 1. Done. Next, the second derivative of this guy. This time we're going to have to use product rule. I prefer product rule. I prefer product rule to the quotient rule. So let's just write np e to the t l. This time it's the argument of t. Let's kind of know, we know that, so let's just do minus 1. That's same as 1 over. So therefore, using the product rule now, noting L is a function of t, so mustn't think that's just a constant there. So let's differentiate. Let's write this guy first. Well, NP is a constant. Constant. Come out of the brackets. Let's e to the t, and then with derivative of L to minus 1. Bring down the power, minus 1. L to the minus 2, and then look in the derivative of L with respect to t. Okay, that's P E T. Next, we write down this, which is a function of t, and look at derivative of et with respect to t as itself there. Then we have that the variance of x is going to be this second derivative of the cumulant generating function valued at t is 0. So we'll have np and then open up the brackets. That's going to be 1 times minus 1. Okay, 1 times minus 1. L to the 0 we know is 1 times p times e to the 0, which is 1, 1 plus that to the 0 as 1 plus e to the 0 as 1. And so what we have is np squared with a minus there, plus NP. Now, common factor NP, and then we're going to get 1 minus P. Yes! Done. I hope I haven't made any kind of blunder there, but the result is right. So that's how you use the CGF, cumulant generating function to find the mean and variance. So it offers an alternative way, possibly a faster way than the MGF to compute like the variance.